Okay, so today we're looking at solving inequalities. Yesterday it was equations, now we're going to throw in a less than or greater than, and that does kind of change things up a little bit. Now the first thing I want to talk about before we jump in and do that is how you should be answering, what your answer should look like. And when you're in Algebra 2 and Algebra 1, we kind of use this inequality notation. In fact, we did it yesterday when we were doing domain. We'd say the x needs to be less than 2 or something like that. Now actually as you progress through math, we don't usually use that inequality sign to represent a range that your value can be. Instead what we use is what we call interval notation. And it's kind of a quick, short little way of showing what your x value can equal. And so basically it's written in parentheses here, where all you do is you put the left number is the lowest your x value can be, and the right number is the highest it can be. So it can range anywhere from here to here. All right, now we use parentheses on this anytime you have a less than or greater than, but if it happens to be an or equal to, then instead of using parentheses, we'll use a bracket. Okay, so let's look at a few of these, and what I want you to be able to do is convert between the two methods really, and make sure if you see it one way, you recognize what it looks like the other way. And then we want to get in the habit of starting to write it like this, and that's what we'll use today. So first of all, on number 1, okay, something like this is called a compound inequality, and it basically says x is bigger than 3, but it's smaller than 8, which is a way of kind of saying x falls in between 3 and 8. Okay, to write that in interval notation, and let me just throw out there a little number line, because sometimes that helps to envision what's going on. Okay, so on a number line, basically I'm saying it can be anywhere from 3 to 8. I would do a closed dot here and an open dot here, and it's anything in between. You remember doing that? Okay, so if I want to write that in interval notation, my lower bound, or the lowest it can be, is 3, and my upper bound, the highest, is 8. All right, and since the 3 is not an or equal to, we would do a parenthesis on that. But since the 8 has an or equal to, we would do a bracket on that side. Okay, and that's the way we would show the values for x. Okay, let's try number 2. This one, when you look at it on a number line, this is all the x's that are greater than or equal to -9. So what that would look like is a closed dot and everything to the right of that. Okay, so now let's look at what your lower and upper bound would be. The lowest it could be is a -9, and that's an or equal to, so we'd put a bracket. But notice that it continues on forever towards the right, and so the upper bound we put as infinity, because it continues on. Now infinity is not really a number, so it can't really equal infinity, so we would always use a parenthesis on an infinity. Okay, one more. Let's say x is less than 2. So that's an open circle at 2 and everything's smaller than that. Okay, so now when you look at this, your lower bound, it goes infinitely towards the left, so your lower bound is a negative infinity. And again, it can't equal that, so we'll put a parenthesis. And then the highest it ever gets is 2, but it can't be 2 because it's not an or equal to, so we'll do a parenthesis on that end as well. Okay, so now that's trying to convert what you've been doing, this inequality, trying to convert it over to this. Now, let's just practice going the other way as well. And sometimes, and it'll depend on the textbook, but our textbook pretty consistently uses interval notation. But let's say you look at the back of the book and you see this. What would that look like in inequality notation? Okay, so on number 4 there, if I look at it on a number line, the lowest it can be is -4, the highest it can be is 7. Both of those are parentheses, so it would look like this and anything in between there. So that's going to look something like this one does. All right, so -4 is my lower bound, less than x, which is less than 7. Okay, let's try some that have some infinities in it. So this next one, number 5, the lowest it can be is -1. That's a bracket, so I'll do a closed dot. And the highest it can be is infinity, so that tells me it's going this direction. Okay, so basically I want all the x values that are bigger than -1. So x is bigger than or equal to -1. All right, last one. I've got the lowest it can be is -infinity all the way up until it hits 14. So it's going to be anything here and then an open dot on the 14 because it's not an or equal to. So then to write that with an inequality, I would say I want all the x's that are smaller than the 14. So x is less than 14. Now, you don't need to create the number line by any means. It's just sometimes nice to visualize that if you're struggling with whether it's supposed to be a less than or a greater than or that kind of thing. Okay, so we're going to use interval notation as we answer today. Now, let's start with inequalities and I say no sign chart is needed because that's probably going to be a new concept for what we're going to learn today is we're going to be doing sign charts. Now, not every inequality requires a sign chart. If you have just a basic linear inequality, like this first one, I'm just going to solve this for x and answer with an inequality. So I would subtract the 2. And then I would divide by -3. Oh, remember though, when you divide by a negative, that's going to switch the direction of your inequality. So x is greater than or equal to -2/3. Okay, so let's practice that interval notation though. I want all the x's that are bigger than -2/3. If it helps, you can sketch it. There's my -2/3, and I want everything bigger than that. Okay, so in interval notation, that means my lower bound is -2/3. It's a bracket because of the or equal to, and it goes on forever towards infinity, parenthesis. Okay, so that's basically just like solving an equation. You just have to watch out for some special things with the inequalities. Okay, why don't you try this one here? It's pretty similar, just a trickier problem to try to solve as far as the algebra. So you pause the video, you do that one. All right, how did that one go for you? I end up with 27ths to infinity for my interval for what x could be. All right, last one I want to try is this here. Notice that it has 2 inequalities in it. We call that a compound inequality. It's almost like having 2 equations there. And really, I just kind of still solve it the same way. I would add 7. It's just that I'm going to look at it as though it's this equation right here and ignore this, in which case I'd have to add 7 to this side. But simultaneously, I'm going to pretend this is not here and look at it like it's just this equation. So when I would add 7, I'd also add 7 over here. All right, so I'm kind of solving both equations at the same time. So this would become 22 less than 3x less than 29. Then I'm going to divide by 3, but I got to do it everywhere. And so then I have 22/3 is less than x, which is less than 29/3. That's that nice compound inequality. That means that x can fall anywhere from 22/3 to 29/3. Since those are not or equal to's, I'll do parentheses on them. And so that's the interval for it. Don't expect pretty numbers. We're kind of done with the pretty number thing. We're okay with fractions, and that's all right. Now, these were all kind of basic inequalities where you just have a single answer. Let's look at something where you might have more than one answer. Okay, so absolute value. Remember yesterday when we did equations, we'd have to set up 2 scenarios to get 2 answers? All right, same deal here. Now, you maybe have done absolute value inequalities before, and you may remember kind of that whole greater, less than kind of trick, and that's fine, but we're kind of going to step away from that mentality because we're going to start doing a lot of other types of inequalities, and they don't all have that nice trick for them. So we're going to just approach this with a sign chart because all inequalities work with a sign chart. And when I say all, not the linear ones that I just did, those are just kind of your basic ones, clear back from Algebra 1. This is like anytime you have two answers, what you might, or really more than two answers possibly. This is how we would approach it. Okay, so I start off, let's look at this first example. And I'm going to treat this like it was yesterday. And I'm going to pretend this right here is just an equal sign for now. So remember yesterday we would get the absolute value by itself. So we'd have the absolute value of 3x, and I'd add that 4 to the other side. And right now I'm pretending it's an equal sign. All right. Once you have the absolute value by itself, you set up your two situations. When you set up your two situations, you get rid of the absolute value and say, well, 3x either equaled 12 or 3x equaled negative 12. Those are your two options. Okay, that means x is either 4 or x is equal to negative 4. And yesterday we were done. That was what we were doing. We were solving. But now what we've got is an inequality, which means we typically will have a range of answers. So here's how we solve this. We look at this like on a number line. And we know that these are actually called critical points. This 4 and negative 4, we call those our critical points. So we put our critical points on our number line. So here's negative 4 and here's 4. And what we're going to do is, at those critical points, is kind of a turning point on whether something is going to work in this equation or a value is not going to work in this equation. So we're going to do test points on our sign chart. So we start over here and we pick a number that would fall down here. And so let's say that's negative 5. Okay, and typically we're not going to create a whole bunch of algebra on this. We're going to do this kind of in our head. So this is negative 5. I'm going to try, because that would be a number that would fall over here. So let's put in a negative 5 right here. So 3 times negative 5 is negative 15. The absolute value makes it a positive 15. And 15 minus 4 is 11. And then I ask you, is 11 greater than 8? And you should say, yeah, 11 is greater than 8. So what we do is we put like a little plus sign, meaning, yeah, that value worked here. If it didn't work, I'd put like a little minus sign, say, nope, that one doesn't work. Now, we have to do this in every area of our sign chart between these critical numbers. So we had this area. So basically, anything down here would work in this inequality. Let's try a value in between these two critical numbers. So pick what's easy. I'm going with 0. Okay, so if we plug 0 in, plug in 0, so that's 0. Absolute value is 0 is still 0. Minus 4 is negative 4. And that is not going to be bigger than 8. So that doesn't work. So I'm going to put a little minus sign to show that that would not work. Okay, last one. Let's pick a number that's going to fall on this side of the critical number. Let's try 5. Okay, so that would get me a 15. Absolute value of that is still 15. Minus 4 is 11. And yes, 11 is greater than 8. So that worked. So I put a plus sign. Okay, so our answer is wherever we had plus signs. Wherever we picked values that did work, then anything in that range would work. So anything here is going to work, and anything here is going to work. But anything in between there would not. So we have to write this in interval notation. So I start with this range here on the left. You always kind of go from left to right, smaller to bigger. So the smallest it can be is negative infinity, all the way up until negative 4. Now this was not an or equal to, so I'm going to do a parenthesis on it. So any value in that range will work. And then what we do is we put a little U-shaped thing in there. That's called in union with. Okay, so all of those values work in union with all of the values here. So let's write that interval. That interval starts off at 4 with a parenthesis because it's not an or equal to, and it goes all the way until infinity. And that is my official solution right there. Any value in those two ranges would work and make this equation true up here. Okay, let's try one more time. First thing I want to do is get my absolute value by itself. It already is. So now we treat it like yesterday, and you set up your two scenarios. That means 1 minus 2x is either going to equal 7, or 1 minus 2x is going to equal negative. Actually, well, I guess they gave it to me as a negative 7. Maybe I should start with that. Equals a negative 7 like it said, but then that means over here I'd have a positive 7. Doesn't really matter which one's which. Okay, so let's solve these individually so that we can find our critical numbers. So let's subtract 1 on both sides. So I'd have negative 2x equals negative 8. Divide by negative 2, and I get 4. On the right side, I'm going to subtract the 1. So negative 2x is equal to 6. Divide by negative 2, and I get a negative 3. So what I have are my critical numbers. So I put those on a number line. And now I have 3 test points. I'm going to try a number on this side of the critical number. I'm going to try a point in between the critical numbers, and then try a number on this side of the critical number. All right, so here we go. We're going to do it mentally. Pick an easy number. I don't know. I'm just going to go with what's small, so I'm going to go with that negative 4 would go there. Okay, so let's look. If you put a negative 4 here, this is basically like a negative 2. So that would turn into a positive 8. With the 1 is going to get me a 9. Absolute value of 9 is still 9. 9 is not smaller than negative 8. That does not work. So I'm going to put a minus sign. Did not work. Okay, let's try in between the two. 0 would be my easy one to try. So when I put a 0 here, that turns this all into 0. 1 minus 0 is 1. The absolute value of that is still 1. But 1 is not less than negative 7. So that did not work. Last one, let's try a number here. Let's put in 5. So if I put in a 5 here, that's going to end up being a 1 minus 10. That's negative 9. But then I have to do the absolute value, so now it's positive 9. And positive 9 is not going to be less than negative 7. That doesn't work either. All right, so now let's look at what that means. If it didn't work anywhere at all, what that means is that it's not going to work anywhere, which means this is a no solution. And that can happen sometimes. And so my answer on this would be no solution. There are no values that I could plug in for x to make this work. If I happen to go plus, 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 then my solution down here would be probably what you're used to writing is all real numbers, but we typically write that in interval notation, and we would call it negative infinity to infinity. Okay, now, I did a lot of work on this one that I want to show you I didn't really need to do, and probably futuristically, probably not gonna. Let's think about, let's use some common sense up here. Look at what you have. You are taking the absolute value of something. What does the absolute value always do to a number? It just makes it positive, right? So tell me, what positive number do you know that's smaller than negative 7? There isn't one, okay? I really glanced at that right off the bat and thought, oh, wait, that can't happen. I can't take the absolute value of something and think it's going to be smaller than negative 7. Won't happen. So in all honesty, I don't mind if you recognize, actually I love it if you recognize that. That's a good thing to see that ahead of time. And then just jump straight down to this right here. I wouldn't mind a quick little explanation saying the positive number can't be smaller than, or can't be negative, or give me something so that I know you just didn't like copy that somewhere. But that's good mental math to be able to look at that and understand the relationships of those numbers and how that couldn't happen. Okay, so there we go. That's how we're going to solve absolute value inequalities. But that's not the only type. We also have quadratics. Now we solved quadratics the other day, and remember how you end up with 2 answers? Okay, so if I throw in a quadratic inequality, then that's going to mean I'm going to have 2 answers, and I'm going to have to do a sign chart with it. Okay, this is probably new. You probably didn't ever do this in Algebra 2. So let's go through it. It really actually is the same deal. You start off and you treat it like it's an equation. So I'm going to pretend this is an equation, and I'm going to factor this. but pretend it equals 0. Because what I'm really looking for are my critical numbers right now. So my factors of 30 that add up to 13, that's going to be 3 and 10. It's a plus and a plus. Set those each equal to 0. I'll end up with a negative 10 and a negative 3 when I do that. So let's look at, those are now my critical numbers. And so I'll set up kind of my sign chart. Always put those numerically on your number line. And let's start doing some test points over here. All right. You can put in a negative. Now, you can actually, well, okay, so let's go ahead. Let's put in a negative, I don't know. Let's put in a negative 11. I'm probably going to have to grab my calculator on this one. So negative 11 is what I'm going to plug in. And sometimes with this one I think sometimes is helpful to maybe jot some numbers down. And so when I put in a negative 11 right here and I square it, that's going to turn into 121. When I plug in a negative 11 right here and take it times 13, I get negative 143. And then I'm going to add 30 to it. Now typically you can go to your calculator and that's fine. If you love that calculator you can do that. But I usually just group these. Kind of going back to what you did in elementary school, you would group things that work nicely. I always just group my positive numbers and I group anything that's negative and I just compare to see which one's bigger. Because really I'm just trying to see, is this going to be bigger or smaller than 0? So when I look at this, these add up to 151. This is a negative 143. My positive number is bigger. So when I subtract it, it's going to end up a positive number. That is not going to be smaller than 0. So that would not work. Okay? I like you to use that mental math, but if you got to plug it in your calculator, then you can plug it in your calculator. Okay, so now we got to try it again. We have to do a value in here. So maybe, again, I'm going to try to keep my numbers small. Let's do like a negative, I don't know, a negative 5, let's say. Negative 5 squared is going to get me a 25. 13 times negative 5 is negative 65. And then I still have my plus 30. Okay, my positives end up being a 55. This is a negative 65. So I'm going to end up with a negative answer. So that, yes, that will end up smaller than 0. So that value in there is going to work good for me. Okay, let's try one more. I have to pick a number up here. Now I usually pick something that's close to it, but gosh, I think I'm going to go with 0. 0 would be somewhere up here. 0 is easy to plug in because that's going to be 0 plus 0 plus 30. So that's 30, and 30 is not smaller than 0, so it's not going to work. So I end up with all the values in here working, but nothing outside of that. So my final interval, what I would write is it works anywhere from negative 10 all the way up to negative 3. It was not an or equal to, so I'm going to leave it in parentheses. And this is the interval of numbers that would work. Anything between a negative 10 and a negative 3 would make this inequality work right here. Okay, let's try one more. I'm going to stick with a quadratic, but again, this method of doing a sign chart is going to work when we do rationals. It just works for all types of inequalities. Now, this one's a little trickier because it's not set up quite as beautifully. Remember, for quadratics, you really need them to equal 0 if you're going to try to factor. So I need to clean this up. Let's get rid of parentheses. Let's get it set equal to 0. So I'm going to distribute. So I'll have a 4x squared minus 12x, and I'm going to add that 9 over here. Okay, so now I've got the 0. Good. So let's factor. But it's going to equal 0. Remember, we pretend that it equals 0 to find our critical numbers. Okay, I've got to find factors that work. I'll probably go with a 2x and a 2x. Let's see how that works. So I can go 9 and 1 or 3 and 3. I'm going to try 3 and 3. Signs are the same because of the positive 9. They're going to both be negatives because I want to end up with a negative 12x. So negative, negative. That gets me a negative 6x and a negative 6x. That's what I want. Boom. Okay, so what's kind of nice here is that you ended up getting the same thing twice. So Now that last time I just did that in my head, but you can always just set those equal to 0 and solve them if you can't do that in your head. So I have 3 halves. The thing is if I do this over here, I'm going to get 3 halves again. So that's kind of odd. That means I only have one critical number. I put it in right here. All right, now I have fewer test points. I only have to test something here, and then I have to test something over here. So let's try this side here, and since that's a positive 3 halves, let's try a 0 over here. Now you can plug it in here. I kind of like this right here after I've distributed it and everything, because it's real quick for me to see, is that going to be bigger than 0 or smaller than 0? So I'm going to use this inequality here, and I'm going to plug in 0. So that's going to be 0 minus 0 plus 9. 9 is bigger than 0. Yes, so that works. Okay, 3 halves is like 1 1/2. So let's plug in a 2. 2 would be over here somewhere. So 2 gets me, and I'll try to squeeze this in, 2 squared is 4 times 4 is 16. Minus, plug in 2 and I get a 24, and then a plus 9. So if I match that up, 16 and 9, that's 25, minus the 24, so that's 1. 1 is bigger than 0. Yes. Okay, so this is one of those examples where you got everything to work. So here's what's tricky about this though. One little tiny detail that's kind of important. All right, any value here works, and any value here works. But the thing is 3 halves by itself actually does not work because it's not an or equal to over here. So it would be an open circle there instead of a closed circle. So actually the exact critical number that I used is not going to work, but absolutely everything else would. Okay, so what that kind of means is that if I were to have plugged 3 halves in right here and here and did all this math, it would have ended up equaling -9, and it's not really allowed to equal -9. Okay, so what that means is I thought it was going to be in all real numbers because it was a plus and a plus, but it's not quite in all real numbers. It's everything here and it's everything here, but it's not 3 halves. So let's show you how you would write that in interval notation. You'd start off on the left and say, okay, it can be -infinity all the way right up until you hit 3 halves. But it can't be 3 halves because of the open circle. In union with. And then you pick right back up at 3 halves. But it can't be that, so I show it with parentheses. All the way to infinity. And this actually, this notation happens quite a bit, where there's like this one exception to it. In this case, the one exception is 3 halves. This is the way that looks in interval notation, and that's usually the way you'll see it in the textbook. Okay, so that's all we've got. Today we're going to focus mostly on those absolute value inequalities and the quadratic inequalities as far as sign charts, but know that that's going to come back to us later on. All right, good luck.